we know that if we throw on a particle from the surface of Earth, it attains some height and again it comes back to Earth again. Now the height up to which the particle reaches depends on the initial velocity of throw. If we throw with higher velocity, it will attain more height. Now if we can throw a particle with such a higher velocity that it escapes the gravitational field of Earth, so that it will not return to Earth again, then this minimum velocity of projection is called escape velocity. So escape velocity is the minimum velocity of projection with which, if a particle be thrown, it can escape the gravitational field of Earth. So we will now see how to find escape velocity of Earth. So let us suppose this small circle represents Earth. Now considering a particle of mass m at the point P, let h be the distance of this particle from the center of Earth. So therefore the particle experiencing a gravitational force at P is g, mass of Earth, mass of the particle, by square of distance square. Now if we want to move this particle from P to P dash, say by a very small distance, say this distance is dh, then the work done can be obtained by multiplying this equation with displacement, that is force into displacement. This is g me m by h square into dh. Now this work is to move the particle from P to P dash by a small displacement dh. So if we want to find out the total work to move the particle from surface of Earth to infinity, we can integrate this equation. Say total work done to move it to infinity can be obtained from by integrating this equation from radius of Earth to infinity. So this is g me m by h square dh. So this is g me m. Integration of h to the power minus 2 is h to the minus 2 plus 1 by minus 2 plus 1. This is radius of Earth to infinity. So this work is g me m. This is minus 1 by h, radius of Earth to infinity, that is minus g me m. Put the upper limit first, infinity, minus 1 by re. So this is coming as g me m by re, because 1 by infinity is 0. So now this can be written as g me by re square, and let us take re common here by this. So this is the work done. Now this is equation number 3. This work is done by providing kinetic energy to the particle. Let v be the velocity, so the kinetic energy given to the particle is half mv square. This is equal to the total work done. This is acceleration due to gravity on the surface of Earth. Let us represent by g me by this thing. So cancel out. So we have v equal to root over 2 g re. Now we have g equal to 9.8 meter per second, and radius of Earth is 6400 kilometer, that is this much meter. So by putting these values of g, acceleration due to gravity, and radius of Earth, we find that escape velocity is coming as 11.2 after converting it to kilometer, it is kilometer per second. So we conclude, if we can throw a particle with a velocity, with initial velocity of 11.2 kilometer per second, then this particle will certainly escape the gravitational field of Earth. This is called escape velocity.